So today I want to talk to you about simplifying big data with Amazon Web Services. Big data is when your data set becomes so large that you have to start innovating on how to collect, store, analyze, and share your data. So there's really 3 V's of big data challenges. There's volume, velocity, and variety. By velocity, I mean that how frequently the new data arrives to you, and what's the latency of that. Variety means is that you have data that comes in various different formats. Data comes in structured ways like schemas, and then there's unstructured data sets like log files or images or binary data. And so the more variety of data sets you have, the larger the problem in collecting, storing, analyzing, and sharing it, and that's what you have in big data. So why big data is so important? The collection and analysis of large amounts of data can really create a competitive advantage for your enterprise. And that's why a lot of enterprises nowadays are trying to analyze and collect that data, the data sets that they have. And really, typically, the more data you collect, the more value that you can derive from it. So let's take a few examples. The more misspelled words you collect from your customers, the better spell check application that you can create. And Yelp is using Amazon Web Services to regularly process customer-generated data to improve spell check on their website. The more searches you collect from the customers, the better recommendations you can provide for customers. Yelp is using Amazon Web Services to deliver features such as hotel or restaurant recommendations, review highlights, and search hints. So all of those features on that website are driven by the customer data, the customer interaction data. The more data you can collect about your customers, the better advertising models that you can create. By incorporating sales data and clickstream data over a long period of time, Razorfish helped Best Buy improve return on ad spend by 500%. As you can see, Best Buy has a large number of visitors, 3.5 billion records, 71 million unique cookies, and 1.7 million targeted ads per day. And so, in a naive instrumentation, you can see that if a user recently purchased a sports movie and is searching for a video game, you can offer them a video game from Xbox. And so analyzing very large volumes of that interaction data, you can really improve the advertising models. Etsy is the largest handmade goods marketplace with last year's revenues of about $600 million. They track customer interactions to figure out what people like and offer them relevant products. So based on the data that they collect, they can figure out your taste. In fact, you can see on this insert here, items matching your taste. So they really dive deep into understanding how you interact with their website. Now, big data grows very quickly. IDC estimates that compound annual growth of big data between 2008 and 2012 is about 62%, and this rate is accelerating. So it really is a big deal. So how do you collect, store, analyze, and share data using Amazon Web Services? Let's talk about the collection part first. Data comes from a lot of different places, right? So you have on-premise or cloud application servers that generate the data. You have databases that continuously generate the data, whether it's transactional data or user data. There's third parties now that provide data sets, right? So you have Twitter data feeds, you have Facebook social graphs, you have a lot of data you can buy with the demographic data. So you can incorporate all those sources together. Amazon has a few technologies that we've shipped in recent years to help you move continuously or periodically the data to the cloud. So we have features such as S3 import and export, where you can literally ship your media to us using FedEx. FedEx sometimes have more bandwidth than a regular connection. You have S3 Gateway, which is an appliance that you can install in your data center. And then you can do, on the background, you can do things like offsite backup, disaster recovery, and data mirroring from that gateway. So the gateway, you write the data to the gateway, and then the gateway does that replication onto the cloud. there is the direct connect feature that allows you to physically connect to Amazon public cloud so you can have low cost, high bandwidth connectivity. And last but not least, you can actually generate a lot of data on the cloud itself by running application servers on EC2, by using RDS, DynamoDB, etc. In addition, there's plenty of open source technologies that allow you to stream data to Amazon. So these are just a few examples of Apache-based projects that you can use to continuously stream data from your application servers into the cloud, into storage solutions, into storage solutions like S3, or directly into Amazon Elastic MapReduce HDFS. So once you collect that data, where do you store it? Let's look at that space a little bit and how Amazon helps there. So where is your data? The diversity of data storage solutions is only going to increase, and there's a good reason for that. Currently, we have DynamoDB, we have S3, RDS, you have on-premise solutions, there's third-party data sets, there's log and application servers. So why do you need all that diversity of data storage solutions? If you look at from this perspective, from perspective of data structure, the data size, and the access pattern, you will need to pick the right solution for your application. For example, S3 is ideal for large unstructured objects, such as files, pictures, binary data, etc. And then DynamoDB is ideal for small objects that you have to read or write at a high speed. So for instance, DynamoDB is a great solution for powering your mobile or web applications. RDS is great for structured schema and standard SQL access, but the size of data is typically limited to a single server. Of course, it's possible to build essentially shards and split data across multiple RDS instances, but this requires substantial development and ops work. That's why it is much more advantageous, for instance, to move, if you need to have very large tables, ideally you do that in DynamoDB. But if you want to have sort of a rigid SQL structure and a simple SQL interface, RDS is a great solution. And so there are a variety of ways you can store your data in the cloud based on the particular need of the application. So analyzing data. First of all, analyzing data, there's a lot of mundane tasks that don't really associate with actual analysis. You have to organize the data. You have to clean it. I'm sure you've seen a lot of times, the record's been misspelled, or address has been misspelled, or IBM spelled in 15 different ways. You can enrich data, where you, for example, can translate IP addresses in your log files, augment that data with the zip codes that are associated with those IP addresses, and then you can get a rich demographic information based on the zip codes, and so you can learn more about your customer base. So let's talk about sort of a concrete example. So we see a lot of customers with the data spread across fairly diverse formats and sources. Imagine that you're an enterprise with a customer sign-up information in a JDBC table. It could be RDS or EC2 or even on-premise database. And you have a purchase history in DynamoDB. If you want to improve your customer targeting, you ought to be thinking how you can merge those two data sets for analysis, right? And then you can start to predict what a user might be interested in and better target your website content. Now, of course, you want to go to store that targeted information somewhere so you can quickly access it while you're generating that customer content. So that might be RDS table. But there's no really reason to stop there, though, right? You've got access to a wealth of other data. Maybe you have clickstream data in S3 that you'll be able to see what your customers are looking at. Or maybe you have access to some social networking data. Maybe you have a Twitter feed where you can incorporate the sentiment analysis about your products or about your content and incorporate that into the targeting models. So all of these things are going to help you better tailor your tailor and target your content. It's tempting to say that you should just migrate all of your data in a single data store. But in practice, it's not really an option. So not only the availability of third-party data sets is not there, but it also, as I mentioned earlier, different applications have very different requirements as far as throughput is concerned, latency, durability, and cost needs. And so as soon as you start dealing with the data produced by multiple data stores like this, you have to address the formats, the different heterogeneous formats as well. And after you've built all those great targeting models, you'd actually want to analyze that data further for patterns and various other intelligent information, and maybe generate weekly, daily, or monthly reports. So let's talk about this orange icon in the middle of the screen. That is Amazon Elastic MapReduce. That's the Hadoop-based infrastructure service that lets you build and deploy applications into the cloud. Amazon Elastic MapReduce reduces complexity and cost of Hadoop management. We manage the clusters for you, so you don't have to invest in system administrator resources and in infrastructure. So you can just completely offload that processing to us. It integrates seamlessly with Amazon Web Services, such as S3 and DynamoDB. And it leverages unmatched operational experience that we have on AWS. There's a lot of use cases that you can apply this technology to, but some of the more popular ones are digital advertising, web analytics, log processing, digital warehousing. And there's a huge, diverse list of industries that are in companies that are using our technology today. Media advertising is really popular with targeting, targeting advertising, as I mentioned earlier. Security is a really popular field where Elastic MapReduce is used in antivirus, building antivirus models so that you can quickly react to new viruses. Fraud detection, both in retail world as well as in credit card processing. Image recognition is really popular field, in the cameras, when you can actually compare images of certain people. Social networking and gaming is a really popular field where games, is a really large analytical space. So there's a tremendous amount of customers that we have, and we've operated well over 1 million of Hadoop clusters just last year, and we've been in business for 3 years now. So we have a really a phenomenal operational experience. And what we do with that operational experience is that we build features and we integrate them into our Amazon Web Services fabric, so you don't have to worry about administrative aspects of that. Forrester Wave Report named Amazon EMR the #1 enterprise Hadoop solution because of its integration with various data stores, its ecosystem of vendors, and the number of customers that we support. So let's talk a little bit about our integration with the rest of Amazon Fabric. So on Amazon EMR and Amazon S3 integration, you can use S3 as a Hadoop file system. So you can store all of your data in S3 with 11 nines durability, and then we have a really high and improved I/O performance to move the data between compute of Elastic MapReduce and the storage in S3. So you can use S3 just as a file system for Hadoop. And so that really removes the necessity of disaster recovery, because S3 has 11-9 durability, job contention, and per application cluster customization. So what you can do is essentially you can launch multiple clusters on top of S3 content, and you tailor those clusters to the problems that you're trying to solve, and not trying to match one single cluster to all of the problems. Amazon EMR and DynamoDB integration gives you an integration at a SQL layer. So you can we have this package called Hive. Essentially it enables SQL-like data query. And so you can have distributed data queries and data movement between EMR and S3, between DynamoDB and S3. You can have filter push down to DynamoDB, and we have built-in throughput and throttling. And so let me actually explain that with a couple of examples. So suppose you have files in S3 and you want to load these files into DynamoDB. You can start by creating a DynamoDB table, and then you can spit up a large Elastic MapReduce cluster, and you can then use EMR to draw the data from S3, take advantage of EMR massive parallelism, and then write this data to DynamoDB. And after running your application for a while, you might want to archive some of that DynamoDB data back into S3, and you can use that same mechanism in reverse. And so you can extract data from DynamoDB and efficiently write it back to S3. So why you want to do that? Let me actually that's a simple code snippet of how you can do that. It's a really simple mechanism. You could just define a table in DynamoDB, define a table in S3, and then just use this code through Elastic MapReduce to do the push. And you can achieve 100,000 of writes per second using that mechanism. So there's various use cases for that. For example, you can archive tables from DynamoDB into S3. You can load data from S3 to DynamoDB, and you can run complex queries with support for things like group by, join, and having, all from Elastic MapReduce. So Elastic MapReduce really becomes a query engine on top of your DynamoDB data. And you can have complex join situations where you want to join maybe a table in S3 with a table in DynamoDB. You can do that with EMR. And of course, once you start running the clusters, Elastic MapReduce cluster, you want to see how it's doing. You want to see how your cluster is performing. And for that, Elastic MapReduce provides 23 different metrics about your cluster through Amazon CloudWatch. So you see free metrics on job progress, cluster health, and resource contention. So for example, you can see how many map tasks are running, how many reduce tasks are running, how much space is left in the HDFS, and things like that. And then you can set up alarms that can tell you when things are going poorly. So for example, if the cluster is idle, if the cluster is not doing anything for an hour, you might want to receive a message saying, hey, shut down that cluster, so we can help you contain the costs. If your HDFS is 80% full, you can set up an alarm, hey, grow your cluster. And we have APIs, by the way, to expand the cluster. And then you can do things like, does the cluster runs efficiently? Does it sort of chew through the work fast enough? And so you can set all those alarms. And of course, you can have web debugging available for you as well, so you can see problems with the application. And there's a lot of third-party tools, such as Karmasphere Analyst, where you can run your jobs and debug them right through the console on their desktop. So that is how you collect, store, and analyze data. Now, what about sharing? When you share your data, you visualize it, you explore it, and you decide you make decisions based on the data. So let's look at a couple of examples here. In this example, you can see where one of our customers, Foursquare, has built this visualization of customer signups from November of 2008 to June 2011. And this visualization helps understand global service adoption over time. You can create very similar visualizations easily with packages such as gplot or our graphical package, and both are supported on top of Elastic MapReduce. You can see that visualization like this can help really bring LinkedIn data to life and make sort of understand your networks better. And EMR integrates with tools like MicroStrategy and business intelligence platforms, so you can build visualizations such as this one directly from Elastic MapReduce. So I hope this presentation helped you understand how you collect, store, analyze, and share data using Amazon Web Services. And now I'd like to introduce you to one of our customers, Jeff Sternberg of Capital IQ, who is going to present some of their big data use cases. Thank you.
Thanks, Peter. So I'm Jeff Sternberg, and I'm from S&P Capital IQ. We are a financial information publisher and analytics platform. We serve Wall Street types, so I'm going to be talking about big data Wall Street style. So I'm going to start a little bit with a boring financial chart, just a very typical trend line over time. It goes up and to the right. It gets a little more interesting or less boring with labels. So what we're actually looking at here is the cumulative transaction value of investment in the information technology sector over the last 10 years. And you can note actually there's a little flattening out in the downturn time of 2008, 2009 related to the recession. But this is a pretty big number. $2.37 trillion invested in information technology over the last 10 years. So, I also wanted to mention that I was able to do this analysis using S&P Capital IQ's transaction screening tools, of course. So shameless plug there. So next, I wanted to think about big data, and this is obviously a pretty hot topic these days and kind of fits in well with the theme of today. So how much investment is happening in big data? So we'll drill into that, and this is a similar chart as before. So this is narrowing the time range down to just the last 3 years, and this is still cumulative transaction value for the IT sector. So this represents nearly 800 billion over the last 3 years, and I narrowed the time range to 3 years so that I could do this chart, which shows us the investment specifically in big data companies. So I did this by limiting the results of my screen, or the scope of my screen, to transactions where the target company contained keywords in their business description for things like data optimization, modeling, analytics, Hadoop, MapReduce, cloud storage, et cetera. And you can see actually there's a little bump at the end, which is Facebook, which I think we'd all agree is a big data company. So using this manipulation, or this data, and rolling it into the quadratic equation, we can actually compute the yearly growth rates of these two valuation trend lines. To do that, we find that the information technology investment is growing at a yearly rate of about 23%, and the investment in big data during the corresponding time range is growing at a rate of 78%. So using this little extra formula here, we were able to solve for y, which is the number of years it will take for big data investment to overtake IT in general. And that's going to be 9 and 9.7 years. So, by the end of the decade, I think big data will completely dominate information technology. So that's my prediction here today. And here's a little curve to just to make that pretty. And with that, I think we can answer the question: big money? Yes, big data is big money. So, and I wanted to talk a little bit about how we at S&P Capital IQ are using Elastic MapReduce in particular. And we're doing it with a recommendation engine, although we're not technically allowed to say recommend, because we're a financial platform and we're supposed to be unbiased, and we're not really allowed to give actual buy, sell, hold recommendations because we're just public data. So we're calling it suggesting data. So what we want out of our platform is a platform that learns from user behavior, right? And some of the examples Peter mentioned, and I'm sure everybody here can get into this. You want a web experience where it's kind of tailored over time to you as the user. And we're no different, even though that our end users are Wall Street investors. And in our particular case, what we want to do is we want to suggest company profiles that the user might be interested in viewing based on their previous click history in our platform, right? So over time, investors are looking at company profiles in Capital IQ, and they're saying, they're basically informing us what's going on with the way they think based on that usage. And unlike, say, an Amazon or a Netflix or something that can use collaborative filtering, we can't do that because our users are, people who work at investment banks or manage investments, and they really don't want their activity to sort of inform someone else's activity, right? Or we don't want any bleed through. So we can't actually provide investment advice, and the clients wind up being, or our clients wind up being, super secret about their deals. But our advantage is that we have lots of great data that we sell on our platform, that we collect, store, and sell. And one of the key data sets is called Key Developments, which is a news product, and we curate news and figure out what are the most important events so that our clients can get smart on a company very quickly. We do searches to catch interesting articles in press releases, and we have a global research team that ensures that the entities are linked correctly, that the news articles, key developments are tagged correctly to the right companies, and that the events are typed correctly with different categories. And so here's just an example of some of this data, just to get a feel for it. This is a dump of Facebook's recent key developments. And you can see things like M&A transactions, lawsuits, client announcements, et cetera. So with our key developments data set, what we wanted to do was get the interesting events that occur in the news. You know, the news is sort of full of sort of regular news, and then there's every once in a while there's interesting news. And we're defining interesting news based on popularity and frequency. So things that are very popular when they occur and don't occur very frequently are more interesting. So that's you know, an example of that in the Wall Street world is something like a dividend increase, right? So if a company has had the same dividend year over year or quarter over quarter, and then suddenly they increase it because they want to return more profits to shareholders, you know, that's an anomaly or an interesting event, and that's going to be recommended higher. We also build a system that we call user selectivity. So I mentioned that, you know, we're tracking or we're learning from user behavior in our platform, and what we want to do is say, you know, based on your usage, do you show a preference for a particular sector? Do you like information technology companies or utilities or energy companies? Do you focus on a particular region of the world, or are you kind of broad? And then, you know, do you care more about private companies or public companies because of the type of investments that you can do? So we create patterns for each user. And the way we do it is we score these suggestions, and we do this in Hadoop and Hive with Elastic MapReduce. We got to be careful to remember to remove items that the user's already seen. And we present it in a widget on our dashboard. And then obviously to tune the algorithm, we want to measure how frequently users click through that, and so that we can iterate the cycle and make improvements. And so this is just a very high-level overview of what it looks like in our platform. So this is my home page when I log into the platform. And the feature that we're talking about here is the companies you may be interested in widget. So this has recommended some companies to me based on my previous activity. And just a couple of quick tips on how we did it, or how the implementation is. So what we do is we actually have a very large set of data that's stored in-house in traditional relational database structure. And we export that data, including the clicks and the key developments, into an S3 bucket, and then compute with Elastic MapReduce the selectivity components, the key development, event typing, recency, and a few other things, and we join those things up together, compute a score, and produce a data output set that we then store back on S3 and then load back into our SQL database. And our web pages, you know, query the data from the SQL database that way. And then if you want to get into a little bit more of the detail, some of the tools that we're using Microsoft SQL Server's BCP utility, which is a bulk copy utility, and we bulk copy data out. And we're using a Windows S3.exe command line application to push data to the S3 bucket. And then we launch a 16-node cluster right now with Hadoop and Hive via a Ruby script. We decided to use Ruby because a lot of the Amazon APIs have nice command line interface wrappers in Ruby. So we kind of control the cluster through this Ruby script. And we actually wind up pushing the Hive data or the Hive scripts and the data, computing, and then kind of hanging out waiting for the job to complete. And then when it's done, we pull it back with that same S3 application and BCP it back into our database. So that's actually the end of my bit. So I think we're going to move on to questions. Peter and I will come up here, and if you guys have any questions, thanks for coming.
All right. Thanks very much, Jeff. And do you guys have any questions about big data? Please, out there. We have a microphone right here.
Can everyone hear me? Can you guys hear me?
We can hear you. Yeah.
Okay, excellent. Question for Jeff. I'm curious, what's the cycle time between updates? How often do you run the MapReduce jobs, and how often would my recommendations change, or what's the minimum time between when my recommendations will change?
Right, OK, cool. So
you repeat the question.
Repeating the question, yeah. So the question is, how frequently does this calculation that I described work for the recommendation system, and how quickly do we update data. So right now, I think our cluster, our job runs in about 8 hours. And so we run that twice a day. And we're thinking of various ways to tune it and maybe run it a little bit more frequently. But many of the events that happen in our platform and our key developments are kind of look back over a week or 2 weeks or a month. And so we think that's a pretty good latency for the use case.
Great. I think I was waiting.
Quick question. So does Capital IQ have long-running EMR jobs? Like, do you have a long-running cluster, or is it like, do you restart them at whenever you need to run the job? And the second related question is, do you do real-time analytics? I mean, Hadoop is not meant for this, but how do you do your real-time analytics and end-user quick response time queries?
Sure. So yeah, the first part of the question is we do spin up a new cluster every time we want to do compute because we only need it for a few hours, and then we shut it down. So actually, EMR is really good at that, and that really fits our use case. And then for sort of real-time stuff, we have a whole bunch of other stuff going on. We don't really use Hadoop at this point for that sort of use cases, but our front-end website has a bunch of real-time capabilities, including stock quotes and various sorts of financial analytics, and so those use other toolkits.
You mentioned that you use a 16-node cluster. How did you guys come up with that number? And have you experimented with other volumes of the size of the cluster?
Yeah, definitely. That's a really good question. We basically started kind of small, I think 2 or 3 nodes, and then we just started iteratively, testing larger sizes, and we found that it's a trade-off between instance types and the number of instances that you have, and then, frankly, how parallelizable is your query or is your Hive code. Hive sometimes has steps that it will, want to use a single map task or a single reduce task, and you have to kind of tweak it a little bit to make it partition or to take advantage of the right number of instances. But it's mostly a process of experimentation, which again is pretty easy because you can try different parameters, you can run tests, and it's pretty easy to get going.
Hey, thanks for doing all this. Really superficially, how would you do a joint query between Dynamo and SQL and RDS?
Right. So
how does that work?
So both Dynamo and RDS, we have connectors in Elastic MapReduce, and so you do it essentially through Hive. So in Hive, you can specify a table in Dynamo. You can say select stuff from a table in Dynamo, and you can join it to a table in RDS. The join itself is going to happen on an EMR cluster. So, but you filter push down the DynamoDB, so you retrieve the relevant data from Dynamo, you retrieve the relevant data from RDS, and then you do SQL join inside MapReduce on Elastic MapReduce.
So it happens inside MapReduce?
It does happen inside MapReduce, right.
There's no data import that goes into first the SQL side, and then the join happens natively as part of the SQL engine? No, the join part happens as a part of MapReduce engine in the EMR. Yeah.
I really enjoyed your boring graphs. They were boring.
Thank you.
So I'm wondering if either of you might speak for a second about real-time visualization experience or tools that you have found valuable, or approaches you found valuable for converting, big data into, particularly into real-time visualization.
Thank you. Yeah. So generally, Elastic MapReduce or Hadoop is a batch processing technology. Now, the batch sizes can be actually quite small. We have customers that have batch size of 5 minutes. Every time they process every 5 minutes. And there's several plotting technologies that people apply and integrate directly with Elastic Mappers. And I mentioned R package, so R graphing, as well as gplot. Those are the two really most commonly used technologies where you can plot, the visualization that was created by Foursquare that I showed in the presentation. You can create those kinds of presentations based on this batch processing and can continuously sort of upload the data points into those visualizations. So your visualization would refresh, so to speak, every 5 minutes. It's not every 5 minutes or every 10 minutes, whatever the frequency is. It's not really real time, but it is sort of a near real time type experience.
What is the language the MapReduce job is programmed, and what is the simple MapReduce job? How many lines of code it will take you?
So traditional Hadoop uses Java to program map and reduce. But there are multiple layers or multiple applications that have been written on top of MapReduce to enable other languages. And so there's Python that you can write jobs in. You can write jobs in Ruby. You can write jobs in SQL-like language, which is Hive. There's this Pig language. That's the name of the language, which is Apache-based language called Pig, which is kind of Python-like scripting language. And in order to write a very simple Hello World Hadoop application, you need roughly 5 lines of code. So starting with Hadoop is actually really quite easy if you're a developer. But even if you're a database person and you know SQL, you can write a Hadoop SQL statement and run it on top of EMR. We have tutorials that you can go through in a matter of 1 hour. That is with spinning of the cluster, with the sample data and the whole soup to nuts. Other questions? All right. Yes, in fact, many customers of ours are using PHP for processing data, and we actually have a tutorial for PHP language as well. Thank you for clarifying.
When do you decide that you should move away from just like a standard scripting language or like a few EC2 instances and decide that you have to go start doing MapReduce? Does that make sense?
Yeah.
Okay.
So it's interesting, if you don't have essentially the big data problem starts when you can't fit necessarily a data on a single machine. That's when you have sort of this distributed data problem. But you don't have to wait to use Hadoop to process data sets. You can set up Hadoop jobs to process your data, however small it is, and then you essentially solve your scaling data problem forever. The more data you have, if you implement it in such a mentality, the more data you have, just add more nodes and your problem is solved. So I would encourage people to think through their problems at a scalable Hadoop way and introduce a Hadoop process into your data processing no matter how large your data sets is. So the couple of things that would happen. Number one is you'll see that you'd want to move more and more data sets to process. You'll be able to integrate it because it's so easy. And number two, the more volume of data you have, the easier it is going to be to scale in the future. So there is really no threshold. I mean, there's a physical threshold over one machine, but there's really no threshold of when you should use Hadoop-like technology. You can start with a data of a couple of 100 megs or even smaller. Do you want to add anything to that?
Yeah, I mean, we basically made the choice to go to EMR over sort of vanilla EC2 just because it was so easy. And the cost was pretty marginal on top of it. So, it was dynamic and easy. And also to the other question about programming languages, we have a lot of SQL developers, and using Hive for us was pretty straightforward as well. There's a few differences between the Hive QL and the standard query language, but it was pretty easy to overcome those and kind of think sort of in a regular sort of SQL way most of the time.
Yeah.
If you're using the data from in Hadoop, would you want to use your main RDS, or would you want to create a duplicate of your RDS before using that information, or would that slow down your current RDS instance? Or
right. So Hadoop is a very powerful parallelization framework. So You can very easily kill your RDS instance with a relatively small cluster, Hadoop cluster, just because it's so efficient of pulling data. And so you have to be a little careful in how you size your cluster to not do that. So the couple of techniques. One is you can actually, you can pull directly from RDS instance that you have for production. The other ones, you can just create SQL dumps in S3, and then you load them from S3 into Hadoop. And a lot of people that have high operational requirement in RDS instance follow that mechanism instead of direct pull, just because Hadoop is so powerful in pulling it.
Hi, I'd like to know if you had some clients or idea of people using MapReduce for image processing, resizing, detection, whatever. Absolutely.
We have, in fact, we have several case studies on the website. You can go and check it out. Image resizing is a very powerful and a bread and butter use case for EMR. But there are a lot of interesting, innovative things that people are doing. There's a company in Korea that uses image recognition using Elastic MapReduce to sort of do like a really nice stalking application. You just upload an image and it surfaces that image on Facebook and everywhere else and just finds all the sources of images that contain that picture, that photo. There's a lot of other image processing that is going on. We have companies that do an interesting copyright searches. So, if your image has been used inappropriately on the internet, they can actually, using image recognition software, figure out which sites are using that image inappropriately. So there's a lot of use cases of image processing on the EMR. Okay.
But how we can customize the MapReduce, for example, to use OpenCV or ImageMagick or those libraries?
You can do exactly that with Elastic MapReduce using this feature called streaming, where Hadoop streams the data into your application on each node and then gets the results back. So Hadoop is a really sort of parallelization and scheduling framework in this case, using that uses the libraries that you already have. You don't have to recompile any of the libraries to use it with Hadoop. You just you pipe the data into Hadoop cluster.
Thank you.
Yep. Please.
I heard that it's basically like a job, and you mentioned something about streaming. The way that I would like to use it, I don't know if I could use it that way, would be that I actually could send a query, and I'm going to get some kind of a response in a timely fashion. Is that possible with EMR?
Yes, it is possible. So the question is, can I send a query and in real time get a result back? It is possible. Many customers are using Elastic MapReduce as sort of a data warehouse with Hive. So you actually have a Hive client. In fact, I've mentioned Karmasphere has one such client. You actually install a desktop application, or you can use free ones like a SQL Squirrel or any other JDBC compliant clients, and you can run Hive on top of EMR, and so you can just type in select star, whatever, and it goes and executes on the EMR and retrieves the results back. Now, how fast? It really depends on what kind of queries you're doing. So if you're doing a full table scan type of queries, Hadoop is extremely efficient. It could be faster than your traditional databases. If you're doing some select queries where you benefit from an index, Hadoop will be slower because Hadoop doesn't have the strategic data placement, etc. But people do run these large data warehouses on Hadoop using exactly the mechanisms that you just asked.
If I increase the processes, would it go faster?
It would go faster. So if you increase the size, Hadoop does have a linear scale, almost linear scale. There's some caveats to that. But yeah, if you add more nodes, you will run faster. So we have several examples. In fact, we have a tutorial on our website about how do you use Amazon Elastic MapReduce as a data warehouse. It goes exactly into those details.
Hi. How would you compare using Hadoop over using an architecture with message queuing and workers with data coming progressively?
Yeah, so how do you compare Hadoop with other scheduling technologies like the message queuing and whatnot? So Hadoop is a great framework that has scheduling, that has fault tolerance, and that has distributed file system. So there's been tremendous amount of investment in Hadoop infrastructure. So while there are others available, there's another frameworks like that. Maybe Condor is another example. Hadoop has just had such a big wave of innovation in it that the question is, why would you use something else? And it's open source as well. So, there's MQs and whatnot. So maybe there's some targeted applications in biospace, for example, that you might use some alternatives. But for general purpose scheduling, distributed file system, and fault-tolerant application development, Hadoop is a really native choice.
Is Hadoop able to get data that is built progressively? With a message queuing system, you just queue data and workers work on it. But with Hadoop, is it only one shot, or you can tell Hadoop to watch from time to time the data that's
Yeah,
there?
you can watch, you can run a continuous job that would just look at the file system and continuously react and change in the file system. Absolutely.
Okay, thanks.
Yeah. So just wanted to mention that we have big data event, the full one-day event on next Friday in Boston, where we're going to go the whole day talking about big data. And we're going to have a hands-on session where our solution architects and developers will be there to help and answer any of the detailed questions about the technology. So please check our website for the big data event in Boston on April the 27th. All right. Any other questions? No? Thank you very much for coming.
Thank you.